All right, so get ready, because today we're going to be looking at the animal kingdom in a whole new way. We're doing a deep dive into this fascinating concept called the genetic book of the dead, and it's from Richard Dawkins. Basically, the idea is that, like, every creature's body, like, down to its genes, it's like a record of all the environments that its ancestors, like, conquered. So it's like their biology is a hidden history book. And we're going to be using excerpts from Dawkins' book to kind of decode all this secret language and uncover the amazing stories that are hidden right in front of us, you know?
Yeah, it's really remarkable how evolution has kind of like left these traces, echoes of the past in every like feather and scale and fin, you know?
Yeah, it's like every creature is walking around with this whole library of information inside them. And Dawkins, he uses this really brilliant analogy to describe this. He calls it a palimpsest. So, those ancient manuscripts where they would write new text over the faded older script.
Yeah.
He's suggesting that an animal's biology is kind of like that, like with the newer adaptations layered on top of the older ones.
Right. Yeah, and it's not just about like seeing those layers.
Yeah.
But it's about understanding how they help us to interpret animal behavior.
Yeah.
And maybe even predict their adaptability.
That's such a good point. So it's not just about like knowing that a giraffe like has a long neck because its ancestors needed to reach those high leaves. It's about understanding how that long neck might affect like its ability to adapt to a changing environment, right?
Exactly, yeah. And Dawkins provides this really compelling example with the Mojave horned lizard. Their camouflage is a perfect match for the desert. But what happens if their environment changes really rapidly? Say, like, because of human development,
Oh, yeah. Like those lizards that end up on a golf course. I remember Dawkins mentioning that. Their camouflage wouldn't be much help there.
Exactly. And it really highlights how an animal's biology is essentially a prediction about the future based on the past. It's like a gamble that their environment will remain somewhat stable.
It makes you wonder how much of our own human behavior is based on those kinds of predictions from our past. Like, I still jump if there's a sudden loud noise, even though I know it's probably nothing dangerous. Like, is that some kind of leftover response from a time when a sudden noise could have meant, like, a predator?
Yeah, that's totally possible. I mean, we carry those echoes of the past within us, too. Dawkins refers to this as, like, the predictive power of genes. He uses this example of, like, a bird adjusting its flight to respond to wind currents. Like, their genes have equipped them with a miniature weather forecasting system based on, like, ancestral experience.
So, in a way, the genetic book of the dead isn't just a historical record. It's, like, also a guidebook for survival, right?
Yeah, that's a great way to put it. And it kind of brings us to this interesting idea of animals as models and model builders.
Okay, now I'm really curious. What does that mean?
Well, Dawkins suggests that animals not only, like, reflect their environment, but they also, like, create internal models of it inside their brains, almost like a virtual reality that's tailored to their specific needs. So like a bat needs a very different model than a frog, you know?
Right. Because a bat needs like a 3D model to navigate in the dark, while a frog might just need to like focus on detecting movement.
Exactly. Each animal kind of constructs this model that's most useful for its own way of life.
That's pretty amazing. So how does that idea connect to this whole genetic book of the dead concept?
Well, those models, those internal representations of the world, are built from genetic information, passed down over generations and generations. So they're a product of evolution, shaped by the successes and failures of countless ancestors.
So decoding the genetic book could actually help us understand not only how an animal's body evolved, but also like how its brain creates these complex models of the world.
Exactly. Like having access to the blueprints for both the hardware and the software.
That's so cool. And speaking of decoding, Dawkins mentions this really cool analogy with Fourier analysis. It's this mathematical concept where complex waves can be broken down into simpler components, right?
Right.
He suggests that maybe, just maybe, future scientists will be able to do something similar with an animal's biology.
Yeah, it's a fascinating idea. Instead of just reading the individual letters of the genetic code, we might one day be able to understand the entire symphony of an animal's evolutionary history.
Yeah.
But to do that, we need to look beyond individual genes and consider the whole picture, the entire organism, or what biologists call the phenotype.
Phenotype.
Right. The phenotype is basically the outward expression of an organism's genes. It's what we actually observe, the physical traits, the behaviors, everything that makes an individual unique.
Ah, so it's like the difference between reading the sheet music and actually hearing the music played.
Exactly. We need to listen to the whole symphony, not just analyze the individual notes. And to fully understand the music, we need to consider the whole orchestra, like the species as a whole. not just the individual instruments, you know.
So the genetic book of the dead isn't just about one animal, it's about the entire species and how it's been shaped by evolution over time.
Precisely. And that's where this concept of gene flow comes in.
Gene flow.
It refers to the movement of genes within a population, like how genes are shared and mixed through breeding. So it's what binds a species together, allowing them to adapt as a collective.
So it's like the species is constantly sharing information, learning from the successes and failures of each individual.
Exactly. And that collective knowledge, those shared experiences encoded in their genes, that's what makes up the genetic book of the dead.
This is incredible. It's like we're just starting to crack open the cover of this fascinating book. And already we're seeing glimpses of this like intricate, interconnected world.
And we've only just begun to explore the first few pages. There's so much more to discover about this remarkable concept.
I can't wait to dive deeper. But for now, let's just pause here for a second and just take a moment to like process all this incredible information. We've learned about those layered adaptations of the palimpsest, the predictive power of genes, those amazing internal models that animals create, and the importance of looking at the species as a whole. It's mind-blowing to realize that every creature around us is carrying this rich evolutionary history inside them.
It really is a humbling thought, isn't it? It makes you wonder, how can we learn to read this genetic book more effectively?
Yeah, it really does make you think about all the hidden stories that are just out there waiting to be discovered. But how do we actually like go about reading this genetic book? It's not like we can just like sequence an animal's DNA and then instantly understand its entire evolutionary history, right?
You're right. It's definitely way more nuanced than that. It's not just about decoding those individual letters of the genetic code. It's about understanding the entire like language of evolution, you know. Dawkins uses this really interesting analogy with the QR code.
Oh, like those like square patterns that you scan with your phone.
Exactly. So like our eyes can't decipher that message that's encoded in the QR code. Yeah. But a smartphone can instantly translate it into something meaningful, right? So Dawkins is suggesting that an animal's body, like its entire genome, it's kind of like a biological QR code, packed with all these hidden messages about its evolutionary journey.
So we need the right tools, like the right smartphones, so to speak, to unlock those secrets. But wouldn't that mean that some animals are kind of stuck with these outdated models if their environment changes really quickly? Like, you know, what we were talking about earlier with that lizard on the golf course.
That's a really crucial point. This genetic book of the dead isn't like a static record. It's a dynamic story of adaptation and change. So some animals are just like better equipped to handle those rapid environmental shifts than others, you know.
All right.
Like think about those species that have survived for like millions of years, like sharks or crocodiles. They must be doing something right in terms of like reading and responding to the book of their environment.
That's true. They've weathered some serious evolutionary storms, haven't they? So if the book is constantly being updated, how does that actually happen on like a species level? We talked about gene flow, but how does that actually play out in the real world?
Well, imagine like a population of birds. Let's say some of those birds have genes that make them just slightly better at finding food in a particular environment. Those birds are more likely to survive and reproduce and pass on those beneficial genes, right?
Right.
So over time, those genes just become more common in the whole population.
So it's like the species is kind of learning and adapting as a whole based on the successes and failures of its individual members?
Exactly. Dawkins calls this process like the species acting like an averaging computer. It's constantly taking in all this data from the environment, processing the results of each experiment, like the life of each individual, and then adjusting the overall genetic makeup of the species accordingly.
That's incredible. It's like the species is collectively writing its own survival guide.
And that guide is the genetic book of the dead. It's not just about the survival of like, you know, one individual, but the survival of the species as a whole.
It makes you wonder what kind of averaging is going on in like the human species right now. With all the changes happening in our environment, technology, like everything, it seems like we're in the middle of writing a whole new chapter in our own genetic book.
Absolutely. And it raises all these like fascinating questions, like what traits are being selected for in this modern world? How are our genes adapting to all these rapid changes? These are the kinds of questions that future scientists are going to be grappling with as they delve deeper into this genetic book of the dead, not just in animals, but in ourselves as well.
It's both exciting and a little daunting to think about all the secrets that are still out there waiting to be unlocked. But for now, let's kind of shift our focus back to Dawkins and this idea of the species as a sculptor. Can you unpack that analogy a little bit more for us?
Sure. Dawkins suggests that natural selection kind of acts like a sculptor, shaping the gene pool of a species over time, like it's a process of constant refinement, chiseling away at that genetic marble to create a form that's just better suited to its environment.
Mm-hmm.
And just like a sculptor might have a vision for their final masterpiece, natural selection is guided by a similar force, this drive for survival and reproduction.
So the individuals that don't survive, the ones whose traits aren't as well suited, they're kind of like those marble chips that fall away.
Yeah, that's a great way to put it. Each generation represents a refinement of the gene pool, a step closer to that, ideal form that's perfectly adapted to its environment.
But wouldn't that mean that, evolution has an end goal? Like a perfect form that a species is trying to achieve?
Yeah, that's a really common misconception. Evolution isn't about, reaching some predetermined endpoint. It's a continuous process, a dance between a species and its environment. That ideal form is constantly shifting as the environment changes. What works well today might be a liability tomorrow.
So it's not about being perfect, it's about being adaptable.
Exactly. It's about being able to read that genetic book of the environment and respond accordingly.
Yeah.
And that ability to adapt. That's what's written in the genetic book of the dead. It's a record of all of a species' successes and failures, its trials and errors, all etched into its genetic code.
It's mind-blowing to think that, every creature around us carries this incredible history inside them.
It really is. And it makes you appreciate the interconnectedness of all life on Earth. Each species is like a thread in this vast tapestry of evolution. And the more we understand those individual threads, the more we appreciate the beauty and complexity of that whole tapestry.
This is really making me look at the world around me in a completely new way. Even a simple pigeon in the park suddenly seems so much more interesting. Knowing that it's carrying all this hidden history in its genes.
That's the power of the genetic book of the dead. It opens our eyes to the wonders of evolution and makes us realize that every living thing has a story to tell.
And who knows what amazing stories are still out there, just waiting to be discovered as we learn to read this book more effectively.
Yeah, that's what makes this exploration so endlessly fascinating. It's a journey without a destination, a constant unraveling of mysteries, and who knows what incredible insights we might uncover along the way.
Yeah, it really is amazing to think about. We're only just starting to decipher this genetic book of the dead. It makes you wonder, what kind of tools those future scientists are going to have. What breakthroughs will allow us to, truly unlock those secrets that are hidden in our genes.
It is really exciting to imagine the possibilities. Maybe they'll develop some kind of advanced imaging technique that'll let us visualize all those layers of adaptations, in an animal's body, almost like peeling back the pages of time,
Oh, wow. Yeah.
Or maybe they'll create some super sophisticated algorithms that can trace the flow of genes through generations and generations, reconstructing the evolutionary tree with incredible precision.
That would be incredible. Imagine being able to see the exact moment when a species branched off from its ancestors, or the point where, a crucial adaptation emerged.
Yeah, it would totally revolutionize our understanding of life on Earth. But even with our current technology, we're making some, remarkable progress. Gene sequencing has become so much faster and more affordable, which gives us access to this wealth of genetic data.
Right.
And with the rise of artificial intelligence, we're developing these powerful tools to analyze and interpret all that data.
It's like we're building the smartphones that we need to scan those biological QR codes.
Exactly. And as we become more adept at reading this genetic book, we're going to gain deeper insights into those forces that have shaped life on our planet.
Right.
From the grand sweep of evolution to those really intricate details of individual adaptation.
Yeah, it really makes you realize that we're all part of this incredible story, this ongoing experiment in survival and adaptation. Even something as simple as our ability to digest certain foods or our susceptibility to, certain diseases. It's all a reflection of our evolutionary history.
It's a very humbling thought, isn't it? We carry the legacy of countless ancestors within our very cells. And as we learn to read their stories, we gain this greater appreciation for the interconnectedness of all life.
It's like we're unearthing this hidden library filled with volumes upon volumes of knowledge, each species, each individual. It's like a unique book just waiting to be opened.
And the more we read,
the
more we realize how much there still is to learn. It's a journey of just endless discovery.
So what does this all mean for us? For the average person who might not have a lab full of all this fancy equipment, how can we start to explore our own genetic book of the dead?
Well, even without all that advanced technology, There are ways to connect with our evolutionary past,
Yeah.
like just paying attention to our own bodies, like our instinctive reactions, our preferences and aversions. That can actually give us some clues about the forces that have shaped us.
So like why some people just like love spicy food, while others can't even handle a little bit of heat.
Exactly. Or why some of us are early birds and others are night owls. Like these seemingly small details might actually be echoes of adaptations from our ancestors, shaped by like the environments and lifestyles they had to face.
That's fascinating. It makes you want to like look at your family history in a whole new light. Like what traits have you inherited from your ancestors? What stories are hidden in your own genetic book?
It's a question worth pondering, isn't it? We all have this unique evolutionary legacy. And while we might never fully decipher all those complexities of our genetic code, we can all become a little more attuned to those whispers of the past that echo within us.
This whole concept of the genetic book of the dead has been truly mind-expanding. It's made me appreciate the wonders of evolution in a way I never thought possible.
I'm so glad to hear that. And remember, this is just the beginning of the journey. As science advances and our understanding deepens, who knows what incredible discoveries await us? Maybe one day we'll be able to read the genetic book with the same fluency that we read a novel, unlocking the secrets of life itself.
That's a future I'm excited to be a part of. And for all our listeners out there, keep exploring, keep asking those questions, and keep marveling at this incredible tapestry of life that surrounds us. Because you never know what amazing stories you might just uncover within your own